Hello, and welcome to the Real Python Guide to Continuous Integration with Python. In this set of videos, you're going to learn the core concepts and benefits behind continuous integration. Next, you'll set up your own continuous integration pipeline. And finally, you'll use that continuous integration pipeline to manage a Python project. So what is continuous integration, or CI? Continuous integration is the practice of frequently building and testing every change done to a piece of code, and then integrating that code as often as possible. In the past, changes were often built weeks apart, causing huge headaches and wasted time when it came time to merge. Frequent builds means that any issues that arise can be traced back quickly and efficiently. CI also involves all developers on a project working on the same repository of code. While different teams and individuals may be on different branches of a repo, they are all working off the same master. This way, as changes are added, all teams have access right away and can see how their code interacts with it. Git is a common version control system, and you'll be using GitHub later on for the example. A big piece of a CI pipeline is automating building and testing. Since Python is interpreted and doesn't need to be compiled, we're more concerned about the testing aspect, but you can think of the build as pulling all the required dependencies for the project. When testing is added to the CI pipeline, you can ensure that a successful commit passes all defined tests, even if the developer forgot to run the test locally. External services are often used to handle CI pipelines, as this eliminates any specific conditions on an individual machine. In the example section, you're going to learn how to use Circle CI, which monitors a GitHub repo for changes, and then builds the project based on a configuration file that you provide. If this seems like a lot to take in, don't worry. In the next section, you're going to set up your own continuous integration pipeline, and things should become clearer. So let's get started. Now that you know the basics behind CI, it's time to set up your own pipeline. Because the goal was to learn how to use CI, the example project and Git process will be rather simple. To get started, log into your GitHub account. If you don't have one, go ahead and create an account. The free tier will be perfect for this project. And create a new repository. Go ahead and call this one Calculator Library. You can leave the description blank. Select either public or private. I'm going to leave mine public. And check the box to add a README, and then also add a git ignore. And you can just start typing in Python, and you'll get a Python-based git ignore file. And create. Okay, now that that's there, you can go to your editor or your terminal, and you can clone this. So I'm just going to do git clone like that. And you should end up in your directory with the folder containing your Git repo. If you're on PC, these commands won't work, and I recommend using the git bash from gitforwindows.org, but any Git client should work. Now that you have the repo cloned to your machine, you need to make and activate a virtual environment. So, going back to the terminal, just going to run Python, and then because we're going to be opening the virtual environment module, we'll do that, and you can just call this like calculator. Once that's been created, you can go and activate it. So calculator bin activate, and you'll know this is working because you'll see the name of the virtual environment in parentheses in your prompt. Keep in mind, if you're on Windows, you'll have a slightly different way of activating it, and you'll need to call the name of the folder, and then you'll have to go into the scripts folder, and then activate. Okay, once you have your virtual environment activated, in the top level of your repo, go ahead and make a new file, and just call this calculator.py. And inside this, I'm just going to copy and paste a set of code. And this is just going to contain the first two of the 4 functions that you'll need to write for your calculator library. So go ahead, save this, and if you look, your calculator library folder should have a Git folder, a git ignore file, this calculator.py, and the README. If that's all correct, back to your terminal or whatever Git client you're using, cd into the calculator library folder, go ahead and add the calculator.py and commit these changes. and just put a message in there, something like add functions for addition and subtraction. All right, so you've got the base of the project set up. In the next video, you're going to add some unit tests so that the pipeline can check functionality of the code. Thanks for watching. Now that the project is set up, it's time to add tests to make sure that we don't lose functionality as we add code. This will be done in 2 steps. Linting to look for potential errors and enforce style, and then unit tests. For linting, you'll use Flake 8, which combines error and PEP8 style checks. PyTest will be used to perform unit tests. To ensure that no tests are missed, you'll also use PyTest Cov, which calculates how much of the code is covered by unit tests. Go ahead and install these using pip, so pip install Flake 8, PyTest, and PyTest-Cov. Because you've added dependencies to your project, you should go ahead and save these in a requirements.txt file. You can do this by saying pip freeze and then a greater than symbol to send the standard output to requirements.txt. Once you run that, you'll have a requirements.txt file pop up in your directory, and this will list all the packages required to duplicate your environment. Okay, if I go back to calculator.py, to run your linter, you can just type in Flake 8 and then add a -- statistics option. And this will check your code for style issues. So you can see it found 2 where it wanted to have an extra blank line, and then the statistics flag sums up everything down here. So if you have quite a few issues that are found, you'll get a nice summary down at the bottom. This should be pretty quick to fix, so just go up to calculator.py and add an extra line in between each of these functions. Now if you rerun that, you'll get nothing there. All right, now it's time to write unit tests. So back in your repo, go ahead and make a new file and call this test_calculator.py. The test prefix is important because this is how PyTest will know that this file contains unit tests. Go ahead and copy the following code, and you should be all set. This will import calculator, and then to test it, it's going to test addition and test subtraction by asserting that you get the right value out of the different methods that you've added. There are plenty of other tests that you could add, but this is good for now. All right, to run the tests, just call pytest -v and --cov and add a period at the end to make sure that it only checks the calculator library directory. If you end up with a ton of output here, it's probably looking through the virtual environment folder called calculator. So let's run this, and I'm just going to bring up the terminal here a little bit more to read it better. So the -v makes it a little more verbose, and you can see which tests pass, which ones failed. And then the cov option shows the coverage, so you can see that 100% of calculator.py is checked. Awesome. So you can see everything passed. And if you look, you should have your gitignore, your calculator, your readme, a requirements.txt, and a testcalculator.py file. There's going to be extra cache folders and your git folder, but your gitignore should check for that. So if you check your status, you can see that you modified calculator to fix the style, and then you've added your requirements and your test calculator files. So let's just git add all of those, and then commit them, and you can say add unit tests for calculator. All right, and to get that back onto GitHub, just do a git push. And there you go. So now that you've defined your dependencies in the requirements.txt file and added your unit tests, it's time to connect this project to Circle CI to set up your CI pipeline. Thanks for watching. Now you're ready to connect a Circle CI pipeline to your project. Before it knows how to run your build, you need to give it a config file in a specific format. Inside your repo, add a .circleci folder. CircleCI will look for a config.yml file in here. So go ahead and make that as well. The .yml file uses a serialization language called YAML, which is designed to be pretty human readable. Go ahead and copy and paste in the following code, and we'll quickly discuss what each line is doing. These first lines are telling CircleCI which Docker container to load up to run your project in. Docker could get its own set of tutorials, so for now, just think of these Docker containers as minimal virtual machines that have just enough resources to run your code. Version is selecting the CircleCI API, and then for jobs, you can specify multiple things that you would like to be checked. If you only have one job, you have to call it build. You then tell CircleCI to go to Docker, and then load this pre-installed CircleCI Python 3.7 container. CircleCI has a bunch of options around running multiple jobs, so if you're interested, you can take a look at their documentation. For example, you could run your code on multiple versions of Python to check compatibility. This working directory goes and creates a temporary directory on the build server to store all the files. Now, take a look at steps. The first thing that it's going to do is check out the repo from GitHub, and then it's going to create the virtual environment and install dependencies. So run says it's going to do a set of steps that you have named install dependencies, and then command is just going to be the actual shell commands to get the environment set up. So it creates a virtual environment, it activates that virtual environment, and then from the requirements.txt file, it installs all the required packages. Once it's done that, it's going to go to the next step, where it's going to run the tests. And it's going to make sure that environment's activated, and then it's going to run Flake8 and PyTest. Okay, so now that this is here, using your Git client, add in these changes, and then commit them. So I'm just going to say something like add config files for CircleCI. Push these to GitHub. And now it's time to go to CircleCI. So stopping over real quick, let's make sure that the repo is updated. You should see everything that you've added, and I can tell right away I made a typo in the folder name, so let's go back and change that. So let me rename this. Make sure, oops. Make sure you spell circle correctly. Let's go ahead and just add that real quick. Push that. Let me refresh. There we go. Cool. And head to CircleCI. When you create your account, you can choose to log in with GitHub, which is what I did. And once you're logged in, you should see this dashboard. So right now I have no projects building on CircleCI. So click on Add Project. And you should see all of your repositories here. So calculator library is what we want. And now for the setup, because you've already added this config.yml file, you can just go right to Start Building. So click on that. And this will bring you to a jobs dashboard. And if everything was correct, you should see success. And you can actually go through here and see what it was doing. So first it was setting up the environment. So there's a bunch of information there. Here's where it checked out the code from GitHub. And then install your dependencies and running your tests. And you can see the same output that you saw before. So now that you've connected your project to CircleCI, it's time to make some changes and see how the pipeline can help you safely modify your code. Thanks for watching. Now it's time to add multiplication and division to your calculator library. Unlike last time, you'll add the test before you write the function. Writing failing tests and then adding code to make them pass is called test-driven development, which is a cool way to do things, because it makes you think about your code and what it should do or not do before you start writing it out. So back to your editor, go to test_calculator and write a test for multiplication that's just called test multiplication self, and then assert that 100 is equal to the result of calculator.multiply 10 and 10. So save this, do a git add all, and then git commit with the message add test for multiplication. Commit that and send it to GitHub. Okay, since CircleCI is watching this, this should trigger a build. So if I go back to calculator library, you can see here's the build running. And I just got the notification, so let me open this up. And there you go. You can see that the build failed. If you go down, you go to run tests, and you can see addition passed, subtraction passed, but multiplication failed. And it's pretty clear why, because it has no attribute multiply, so it's time to go ahead and add that. So back to the editor, go to calculator.py, and define multiply with a first term and a second term, like so. And you can just return first term times second term. Save that. Add it to your repo by adding it, committing it. I'll just say add multiply function and push it. Okay, back to CircleCI. Let's go back to calculator library, and you can see there's a new job that's running for adding the multiply function. Let's open this one up, and look at that, success. Let's go back down to run tests, and you can see now test multiplication passes. So there you go. You should be getting the hang of this by now, so go ahead and try to add a test for division to make the build fail, and then go ahead and add in the function to make it pass. These have been relatively quick builds in this example, but sometimes it can take quite a while for all the tests to run through. The nice thing with using an external service like CircleCI is that you can work on something else while the build is being checked. I have my account set up to send me emails if a build fails, so I can do something else and then come back once it's ready. There are other options too, so if you click on the little settings button, you can go down to chat notifications and you can integrate it with Slack or IRC. Another cool thing with CircleCI is how it integrates back into GitHub. So if we go back to the repo on here, and let me refresh this because we've added some more commits, and if you click on your commits, you'll actually see check marks and X's where a build failed or a build succeeded. So this can be a very quick way on GitHub to go back and see, what actually caused, what new code was added to cause this to fail. Okay, so that's a quick overview of how to put CI into some of your projects. In the next video, we'll wrap up by seeing what some of the next steps you can take are. Thanks for watching. While this was a very high-level intro to CI, you now have an incredibly powerful tool to help you with your projects. CI incorporates a number of topics that we only skimmed over, so if you want to get deeper into it, here are some good next steps. Each team usually has its own workflow with Git and how they incorporate code together. A common tool is adding in peer review, where other developers check code before it's merged back into the master branch. Check out the RealPython Advanced Git Tips for Python developers if you're looking to learn some new tricks. While we use the built-in VENV environment manager, there are a number of package and environment managers available for Python developers. Popular options include Conda and pipenv. Conda is well known across the data science realm as it includes a number of tools out of the box for analysis and visualization, while pipenv is becoming more and more popular. If you'd like to learn more about pipenv, check out the RealPython guide on it below. For testing, we only covered the bare minimum of tests required to make the pipeline work. There are so many aspects to testing code effectively, so take a look at the Getting Started with Testing guide if you want to take your skills to the next level. A common final step in a CI pipeline is to create a deployable artifact, which is a finished package unit of work that can be deployed to users or included in other projects. This is a great precursor to continuous deployment or continuous delivery, which is the constant delivery of software to multiple stages of deployment. It ensures that new features are developed and sent to users as soon as they're ready. This is so often used with CI that you may be more familiar with the term CI/CD than just CI by itself. There's a link to a great site below explaining the benefits and strategies to CD. And that's it. You should have a pretty good idea of how you can add continuous integration to your projects. It's time to go try and set up your own pipelines for your projects and see all the cool things you can do with them. Thanks for watching.